Hello students, in this lecture you will learn about electric dipole and we will see how to find electric field due to electric dipole. So first we will recall some fundamental things which you have studied earlier and which will be required for the study of electric dipole. The first we state a binomial theorem. The binomial theorem gives the expansion of 1 minus x raised to n. N is the integer and x is the number smaller than 1. Now it is a infinite series, but I have written only first two terms because higher terms will be neglected because they will be very small as compared to 1. The actual binomial theorem is 1 minus x raised to n equal to 1 minus n by 1 factorial x raised to 1 plus n into n minus 1 divided by 2 factorial into x raised to 2 minus n into n minus 1 into n minus 2 divided by 3 factorial x raised to 3 plus up to the infinite term. So here you will find that the signs alternate plus, minus, and so on. But we are not interested in the higher terms because what happens is x is very small. Suppose x is 0.1, then x square is 0.01, x cube is 0.001. So they become smaller and smaller and that will be negligible as compared to 1. So what we require for the study of the electric dipole are only first two terms, higher terms will be neglected. Then the magnitude of the electric field due to point charge at distance r is E equal to 1 upon 4 pi epsilon 0 q by r square. In the vector form, we can write it as vector E equal to 1 upon 4 pi epsilon 0 q by r square into unit vector of r. Then unit vector can be written as vector r divided by r, and after simplifying you get 1 upon 4 pi epsilon 0 q by r cube into vector r. Now let us see what is the electric dipole. Electric dipole consists of two equal and opposite charges. So plus q and minus q separated by small distance. So distance between them is very small. Now why the distance is very small, I will come to that little later. Before that, we will define one physical quantity for the electric dipole called as the electric dipole moment. The symbol for that is P and it is equal to 1 of the charge into distance between the two charges. So Q into L. L is the distance between the two charges. This electric dipole moment is a vector quantity. Its SI unit is charge coulomb, length meter, coulomb meter. And since it is a vector quantity, this is its magnitude and its direction is defined from minus q to plus q. Now let us see why we have mentioned here the two equal and opposite charges separated by small distance. The application of the electric dipole will come across in the molecules. The molecule in fact is the electric dipole. It has certain electric dipole moment. The molecule is made of one or more atoms. Each atom is made of positively charged nucleus and negatively charged electrons. Now these positive charges of nuclei are at a different point because there are different atoms are there in a molecule. So positive charges are at different point, but as far as a force is concerned, they will act from one point and that is called as a center of positive charge. Just like a center of mass. Mass may be distributed all over, but mass will act from one point. Similarly, positive charge of the molecule is at a different point in the nuclei and they act from one point, that is called the center of positive charge. Similarly, electrons in an atom and in the different atoms in a molecule, They are at different position, but all these electrons which are negatively charged will act from one point that is called as a center of negative charge. Now this center of positive charge and center of negative charge, they lie within the molecule itself. So distance between the center of positive charge and center of negative charge is very small because molecule is very small. So distance is very small. So molecule behaves like an electric dipole. So now we'll find the expression for electric field due to the dipole. Now here in this diagram, this is a charge plus Q and this is a charge minus Q separated by the distance L. So this is the dipole, plus Q minus Q separated by small distance vector L. Now this vector L, I have shown a direction from minus Q to plus Q because the direction of dipole moment is from minus Q to plus Q, and vector P equal to Q vector L. So that's why direction is from minus Q to plus Q for vector L. Then this is a dipole and we have to find the electric field at the point P due to this dipole. Now this, to specify the position, what we will do here is, we draw mark the origin. Actually it is a coordinate system. What is important for us is the origin of the coordinate system. The position vector from O to P is vector R. So that is the position vector of the point P. Then let us say that position vector of minus Q, the vector from O to minus Q, is vector R dash. Then we use the law of triangle vector to this. So vector R dash plus vector L, that is this, from vector from here to here, this vector R dash plus vector L is the position vector of that charge plus Q. Then again here we apply the law of triangle of vectors. So this is R dash, then plus R minus R dash, that is equal to R. So in law of triangle vector, this vector plus this vector is equal to this vector. So we have specified here, this is a distance in fact, this is also distance, these are the position vector. Then electric field at the point P. So here we write vector E in bracket vector R. So vector R is the position vector. So it shows that vector E in bracket vector R means electric field at this position specified by position vector R. Now electric field at this point is due to charge minus Q and charge plus Q. So electric field at the point P due to charge plus Q, vector E suffix plus Q, but where what is the position with respect to Q? It is, see, the R minus R dash. Now L is in this direction. So if you reverse it, it will become minus L. So this direction of vector L is from minus Q to plus Q. So minus vector L is from plus Q to minus Q. So these two vectors you add, that is R minus R dash minus vector L. So this is the electric field due to the charge plus Q. Then electric field due to charge minus Q, we write vector E suffix minus Q, and from here to here distance is R minus R dash. Then we'll use the formula which we have stated in the earlier slide. Electric field due to charge plus Q is 1 upon 4 pi epsilon 0 Q and into that position vector divided by magnitude of the position vector Q. Then because of minus Q, electric field is 1 upon 4 pi epsilon 0 Q, charge is in fact minus Q, and the distance of that is vector R minus vector R dash divided by modulus of that Q. Now another way of looking at the minus sign is, see, electric field at a point P, due to minus Q, it is towards directed radially towards the negative charge, and because of plus q, it is directed away from the positive charge. So this direction and this direction of electric field due to the positive charge is this way, electric field due to negative charge is towards the negative charge. So they are in opposite direction, so that's why sign is minus. Then next step, we take out that q, and what remains there is q by 4 pi epsilon 0 in bracket this term minus this term, and call this as equation 1. And now we have to simplify this. So what next we are going to do is, we will evaluate this 1 by modulus of r minus r dash minus vector L raised to q, and that will be done in the next slide. We have evaluated up to this equation 1. We have found this expression vector E equal to these terms. Now we will try to find out what is 1 by modulus of r minus r dash minus L vector L q. So we consider this 1 by modulus of vector r minus vector r dash minus vector L q. Then we take this in the denominator, so 3 becomes minus 3. Then next what we do is, we multiply and divide by 2. So when you divide by 2 here, it becomes minus 3 by 2, and when you multiply by 2, it comes here. So 2 into minus 3 by 2 is minus 3. Then we will find the square of this. It is x minus y square. This is x square minus 2xy plus y square. Now here, this is a vector. So just like vector A dot vector A equal to the modulus of vector A square. See, vector A dot vector A equal to A square. A square means modulus of vector A square. Same way here, x square. So this square of this. So vector r minus vector r dash dot vector r minus vector r dash, that is modulus of r minus r dash square, minus 2xy. So x is this and y is this vector L, and dot product you have to write there in between. Then plus y square. So plus y square, y here is vector L, square means vector L dot vector L, which is L square raised to 3 by 2. Then we take this r minus r dash square modulus square out, and what remains inside is 1. Here vector r minus r dash square was not there, so we divide it. Here vector r minus vector r dash square was not there, so we divide by that. Then next we take this, so in fact this raised to minus 3 by 2 is modulus of r minus r dash minus 3. We take it out, so that is becomes modulus of r minus r dash minus 3. Then it is written down as plus 3. So when it is taken out, what you get is modulus of r minus r dash raised to minus 3, that is equal to 1 by vector r minus r dash q, and remaining thing is written as it is raised to minus 3 by 2. So we had come up to this in the previous slide. Now here for this bracket we use a binomial theorem. According to binomial theorem, 1 minus x raised to n equal to 1 minus nx plus some higher terms are there. Now here n is minus 3 by 2 and x is this two terms are x. So 1 minus x raised to n is 1 minus n is minus 3 by 2 x. So this term is also there, but this L square is there. L is very small. Square of that will be still smaller. We are going to neglect it. So that's why I am not writing it. So this we get by using the binomial theorem. Then you take this inside. So when this goes inside, 1 minus modulus of r minus r dash cube. Then minus minus plus, 2 into cancels. So 3 remains there. So r minus r dash dot L divided by this cube and this square is pi. So modulus of r minus r dash raised to phi plus higher terms. Now in the previous slide we have come up to this. Then earlier slide we had written this equation 1, and we wanted to find out what is 1 by modulus of r minus r dash minus vector l raised to 3. So now we already found it in the previous slide. So now what we do is we substitute this in this equation. So vector E, again it was a function of vector r, that q upon 4 pi epsilon 0 here is common. Then this 1 by vector modulus r minus r dash minus vector l raised to 3, we substitute that here. Now this will remain in the numerator, r minus r dash minus l divided by this term plus this term, which is vector r minus vector r dash minus l into this is written here. Then here this is the second term of that equation 1. So this term is first term, second term, and dot dot dot, and what is written here last is this term. Okay, so it is minus r minus r dash divided by modulus of r minus r dash cube. So this first term is this part, then second term is this part. Then this r minus r dash minus l is split into two, r minus r dash and minus l. So r minus r dash divided by modulus of r minus r dash cube is this, minus l by modulus of r minus r dash cube. Then second term we write it as it is. Then here, then other things we write as it is. Now this first term and the last term cancels. So what remains is second term and the third term. The third term I am writing it here as it is, and second term I am writing here next. Then here I have not included here dot dots, that means higher, so we neglect higher order terms. I mentioned earlier that the application of the dipole is in the molecule. The molecule is an example of the electric dipole, where there are center of positive charge and center of negative charge. But molecule is very small and this center lies in the molecule itself. So distance between these two centers is very small. So molecular dipole is a short dipole. And this for a short dipole, it is the distance is so small, it is almost like a point. So the distance between the two centers of charge is tending to 0. Comparatively, each charge is large, so charge tending to infinity. In mathematics, whenever one term is tending to 0, other term is tending to infinity, their product is finite. So QL will be a finite quantity. Then under this, that short dipole is called as a point dipole. And as we defined earlier, that Q vector L equal to vector P. See, Q is the charge, one of the charge of the dipole, and vector L is in fact a distance from minus Q to plus Q, and vector P is the electric dipole moment. And now, what the expression which we have found for the electric field in the previous slide, that vector E of is a function of vector R. So this is the electric field, it is called. So it is called the vector field. So there, that Q vector L, so this Q which was here will take inside. So Q vector L is vector P. So Q which was here is taking here, and vector L was there. Q into vector L is vector P. So this is the final expression for the electric field at a point due to the dipole.